Assalamu alaikum. So this will be our first lecture in Control Systems EE 440 for the fall 2020. So at first let's go through the syllabus. The syllabus already posted on the e-learning. Now this course is 3 credit hours, and I will teach this course with Professor Saleh Rudaide. For the office hour, you can choose whatever slot is good for you by appointment. Simply send an email and I will answer. For the textbook, we have the Modern Control Systems for the DORF. It's the 11th edition. And for other references, let's say, we have the OGATA, and also we have the Feedback Control of Dynamic Systems for Franklin, and also we have another reference for your use, which is the Feedback Control System. Now, in general, the control systems will cover the following topics: transfer functions, block diagrams, signal flow graphs, state space description, mathematical modeling of physical systems, time domain analysis, root locus techniques, frequency domain analysis and design. This course has a prerequisite, which is the signals and system. The code is EE260. And in general, we have the following outcomes. After finishing this course, the students should demonstrate understanding the open loop and the closed loop control systems and their physical meaning, a knowledge of constructing a mathematical model of physical system via transfer function and state variable method, the ability to analyze the system behavior and the stability using mathematical model, and evaluating the system performance in time domain, the understanding of the analysis and design of systems in frequency domain, and finally a knowledge to implement controller design techniques to make the system behave, satisfy design objective. In order to satisfy certain design objective, you should design a controller for that. Now this course, the student learning outcome are the first and the second of the ABIT, and simply we will cover the following topics or the following chapters in the textbook. In the first week, we'll try to cover introduction to control system, understanding the meaning of the control system, the components, the main components of the control system, the difference between open loop and the closed loop control system, and the importance of stability, sensitivity, and so on. Next, for the first and the second week, we'll discuss the mathematical modeling of the system, which is chapter 2 in the textbook. After that, we'll go to the state space representation, which is actually a representation of the system in time domain, which is chapter 3. Then feedback control system characteristic. After that, we'll discuss the performance of feedback control systems. Then the stability of linear control system. After that, we'll discuss the root locus design method, how to design the controller using the root locus method. After that, we'll cover the frequency response method, the stability in the frequency response, and finally the design of feedback control system. Of course, the topics can be mixed, can be skipped, and then we return back to the skipped, let's say, topic according to the flow of the course. In general, we will have one midterm in the university and the final exam also in the university. So 30 points for the midterm exam and 50 points for the final exam. The remaining points are 20 Those will be for the homework, quizzes, performance. Let's say sometime I will ask questions, and if anyone answer, I will give 1 point. Sometime I will give quizzes. Sometime I will assign, let's say, suggested problem or homework. Of course, this will depend on the sequence or let's say the flow of the course. Of course, the date will be according to the university calendar. In general, the university will specify the midterm and the final exam. For the quizzes, sometime you should be ready all the time, actually. Now, if we give homework in this course, it must be submitted within a week from the announcement of the homework. For the attendance policy, you must consist with the university policy for that.